Hi dear children, welcome to today's class. Today we are going to discuss exercise 1.2, second exercise of the chapter, real numbers. The first question, express each number as a product of its prime factors. Express each number as a product of its prime factors. We need to express the given numbers as the product of its prime factors. The first one is 140. First one is 140. The prime factorization 2, then we will have 70. 70 into 2 is 140. Then again 2, then 2 into 35, that is 70. And 35, the prime is 5. 5 into 7, that is 35. So the prime factorization corresponding to 140, that is 2, we have 2 times. So that we will write it as 2 square into 5 into 7. The next number is 156. 156. The prime factorization corresponding to that is 2 into 78, 156. Again 2 into 39, that is 78. Now 3 into 13, that is 39, and we know that this 13 is a prime number. So the prime factorization corresponding to 156. Here also we have 2 times. So 2 square into 3 into 13. 2 square into 3 into 13. Next one is 3825. 3825. 3 into 1275. 3 into 1275, that is 3825. Again 3 into 425. 3 into 425, that is 1275. Now 5 into 85, that is 425. Now 5 into 17. 5 into 17, that is 85. So the prime factorization corresponding to the number 3825. 3825, that is equal to, here 3 repeats 2 times. So 3 square into 5 repeat 2 times. So 5 square into 17. Next number 5005. 5005. So this is 5 into 1001. It is 7 into 143. It is 11 into 13. Okay. So the prime factorization corresponding to this is 5 into 7 into 11 into 13. 5 into 7 into 11 into 13. That is the prime factorization corresponding to 5005. Now I am going to do the second question. In second question, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of two numbers. Okay. In second question, we need to find LCM and HCF, and we need to verify whether HCF into LCM is equal to product of two numbers or not. That we need to verify. So the first sub question is 26 and 91. 26 and 91. The prime factorization corresponding to 26 is 2 into 13. 2 and 13. And 91, the prime factorization is 7 into 13. So 26, that is equal to 2 into 13. 91 is equal to 7 into 13. Now, first I am going to find HCF. So HCF is equal to, HCF means we need to list out the common prime factors. Okay, just look at these two, and the common prime factors in these two prime factorization, that is 13. So HCF, we have only one common prime factor, and here we need to write the smallest power of that 13. And in these two prime factorization, the power of 13 is 1. So the smallest power is also 1 itself. Now LCM is equal to, we need to list out all the prime factors present in our prime factorization. Okay, so that is 2 into 13 into 7. 2 into 13 into 7. And here we need to write the greatest power. Greatest power. And just look at this prime factorization. We know that the greatest power of all these prime numbers is 1. So this is our LCM. And LCM we will get it as 182. LCM is equal to 182. Now we need to verify whether HCF into LCM is equal to product of these two numbers. 26 into 91. 26 into 91, that is 2366. 2366. And the LCM into HCF. LCM into HCF, that is equal to 13 into 182, that is also 2366. Therefore LCM into HCF, LCM into HCF is equal to product of that two numbers. Product of two numbers. Hence the result is verified here. The second pairs 510 and 92. 510 and 92. The 510 factorization corresponding to 510, 2, 225, 5, 51. So this 510 we can write it as 2 into 5 into 51. 2 into 5 into 51. And 92. 92, the prime factorization corresponding to 92 is 246. And 46 we can write it as 2 into 23. So 92 is equal to 2 repeats 2 times, 2 square into 23. 92 is equal to 2 square into 23. Now we need to find out the LCM and HCF, and we need to verify whether the result is true or not. So HCF is equal to, we need to write the common prime factors. We need to write the common prime factor. Here the common prime factor is 2. And the smallest power, here the power is 1 and here the power is 2. So the smallest power is 1. So HCF is 2. Now LCM is equal to, just list out all the prime factors present in the prime factorization of these two numbers. Okay, that is 2, 5, 51 and 23. Now write the greatest power. The greatest power is 2, 5, 1, 51 raised to 1, 23 raised to 1. And this we will get it as 23460. 23460. Now we need to verify the result. So LCM into HCF is equal to, LCM into HCF is equal to 23460 into 2, that is equal to 46920. 46920. And the numbers, that is 510 and 92, the product of that two numbers is also 46920. Hence the result is verified here. Now the third sub question, 336 and 54. 336 and 54. 336, the prime factorization is 2168. Again 284, 242, 221, 37. This is the prime factorization. And 54 we will get 227, 3933. Okay, so the prime factorization corresponding to 336. is equal to 2 repeats 1, 2, 3, 4. That 2 repeats 4 times. So we will write it as 2 raised to 4 into 3 into 7. And 54 is equal to 2 into 3 raised to 3. 2 into 3 raised to 3. Now we need to find out the LCM and HCF. HCF is equal to, we need to find out the common prime factors. 2, 2. So 2 is a common prime factor and 3 is also a common prime factor. Now the smallest power. Here the power of 2 is 4 and here the power is 1. So the smallest power is 1. And here the power of 3 is 3 and here it is 1. So the smallest power is 1. So HCF is equal to, we will get it as 6. Now LCM is equal to, just list out all the prime factors present in this prime factorization, that is 2, 3 and 7. Now the greatest power. The greatest power of 2 is 4 and 3, here we have 3 raised to 3 and 7, the power is 1. So we will get LCM is equal to 16 into 27 into 7, that is equal to 3024. 3024. Now the LCM into HCF. LCM into HCF is equal to 6 into 3024. 6 into 3024, that is equal to 18144. 18144. And the numbers, they are 336 and 54. So 336 into 54 is equal to 18144. Hence the result is verified here. Okay. Now the third question. Third question, 3 numbers is given and we need to find out the LCM and HCF of that 3 numbers. Okay, second sub question I am going to do 17, 23, 29. 17, 23, 29. Okay. 17, that we know that the 17 is a prime number, 23 is a prime number and 29 is also a prime number. The given 3 numbers are prime numbers. Okay. Now HCF. So the prime factorization corresponding to a prime number is that number itself. So HCF is equal to, what is our HCF? We need to write the common prime factor. Is there any common prime factor? Okay, these 3 numbers are prime numbers. So there is no common prime factor. In that case, we will write HCF is equal to 1. HCF is equal to 1. Now LCM is equal to, we need to list out all the prime numbers present in the prime factorization. That is our given numbers itself. Okay, that is our given numbers itself and the power of that numbers is 1. So this we will get it as 11339. 11339. So dear children, just keep it in your mind. If the given numbers is a prime number, then the HCF of that number is 1. HCF of that number is 1 and LCM, just take the product of that numbers, that is the LCM. So in general, if P and Q are 2 prime numbers, if P and Q are 2 prime numbers, then the HCF of these 2 numbers, HCF of P and Q is equal to 1 and the LCM of P and Q, that is equal to PQ. LCM of P and Q, that is equal to PQ if P and Q are prime numbers. Now the third sub question, 8, 9, 25. 8, 9, 25. The prime factorization corresponding to 8 is 2, 4 and 4 we can write it as 2, 2. Thus 9, 3, 3 and 25, 5, 5. Okay. So 8 we can write it as 2 raised to 3. 9 we can write it as 3 square. 25 we can write it as 5 square. Now HCF. HCF is equal to HCF. Here we need to find out the common prime factor. Is there any common prime factor? We don't have any common prime factor. Therefore, this HCF is equal to 1. Now LCM is equal to, we need to list out all the prime factors present in that 3 numbers, that is 2, 3, 5. And the highest power, that is 2 raised to 3, 3 square and 5 square. 2 raised to 3, 3 square and 5 square, and this LCM we will get it as 1800. LCM we will get it as 1800, and in this case the HCF of these three numbers is equal to 1. Then we can say that these three numbers are co-primes. If the HCF of two numbers or the three numbers equal to 1, then we can say that numbers are co-primes. Now the fourth question. HCF of 306, 657 is equal to 9, and LCM, find LCM of 306, 657. Okay, HCF of two numbers is given. We need to find out the LCM, and we know that result HCF into LCM is equal to, here the numbers is 306 into 657, product of two numbers. HCF into LCM is equal to product of two numbers. So LCM is equal to 306 into 657 divided by HCF, that is 306 into 657 divided by 9, that is equal to 22338. Okay, this is the LCM of 306 and 657. Fifth one, check whether 6 raised to n can end with the digit 0. Check whether 6 raised to n can end with the digit 0 for any natural number n. Okay, so if you want to say a number is end with the 0, okay, 10 this end with the 0, and the prime factorization of this, we know that 2 and 5 will be there. And if you took 20, that's also ends with the 0. In this prime factorization also you will have 2 and 5. So in general, if a number ends with 0, then the prime factorization of that number will contains 2 and 5. Okay, if a number ends with 0, then the prime factorization of that number should contain the primes 2 and 5. Okay, if the prime factorization corresponding to a number that contains 2 and 5, then that number ends with the 0. So we will check here. This 6 we can write it as 2 into 3 raised to n. 2 into 3 raised to n. That is 2 raised to n into 3 raised to n. So the prime factorization corresponding to 6 raised to n, that is 2 raised to n into 3 raised to n. Here we know that 2 is there, but 5 is not there. 5 is not a prime in the prime factorization of 6 raised to n. So this number is not end with digit 0. There is no natural number n for which 6 raised to n ends with the digit 0. If it ends with the digit 0, then the prime numbers 2 and 5 will be there in the prime factorization. Here 2 is present but 5 is not there. Therefore, there is no natural number n for which 6 raised to n ends with the digit 0. Sixth question. Explain why 7 into 11 into 13 plus 13 and 7 into, second one is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Okay, we need to explain why these two numbers are composite numbers. Okay, we know that every composite number we can express it as a product of prime numbers. Every composite number we can express it as a product of prime numbers. Okay, so just consider this number. We know that in the first term and the second term 13 is common. So I will take that 13 outside. So 13 into, if you took 13 outside from the first term, we will have 7 into 11, and in the second term 1 will be there. Okay, that is 13 into 7 into 11, that is 77. Okay, 77 plus 1, that is 13 into 78. and the factorization corresponding to the 78 is 13 into 2 into 3 into 13. Okay, this 77, the factorization, 78, the factorization is 2 into 3 into 13. So here we got it as 2 into 3 into 13 square. 2 into 3 into 13 square. That means we expressed the given numbers as the product of prime numbers. Therefore, this is a composite number. If you can express a number as the product of prime numbers, then that is a composite number. Now, the second one, that is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here also 5 is common. Take it common. And then we will get 7 into 6 into 4 into 3 into 2 into 1 plus 1. Okay, that is actually 5 into 1009. 5 into 1009. This 1009, that is a prime number. That means we expressed the given number as a product of prime numbers. Therefore, that is also a composite number. Now, the last question in that exercise, that is 7th question. The question is, there is a circular path around a sports field. Sonia takes 18 minutes. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the same starting point? Okay, here for Sonia takes 18 minutes and Ravi takes 12 minutes, and we need to find after how many minutes they will meet again at the same starting point. Okay, that after how many minutes means we need to find out the LCM of 18 and 12. LCM of 18 and 12. So 18, the factorization is 2 into 9, 3, 3. And 12, that we can write it as 2, 6, 2, 3. So 18 is equal to 2 into 3 square, and 12 is equal to 2 square into 3. Then LCM, just list out all the prime numbers, that is 2 and 3, and the highest power of 2 is 2 square and the highest power of 3 is 3 square. This is 4 into 9. 4 into 9, that we will get it as 36. That means after 36 minutes, Sonia and Ravi will meet again at the same starting point.